Apologies to any George Harrison fans out there. As any little kid will tell you, our sun is a big ball of fire in the sky, and it's only small because it's so far away. The second part's true enough, but the sun is simply our parent star, and it works primarily through the process of nuclear fusion. Yep, that's the same fusion process we are trying to harness here on Earth in order to have almost unlimited clean power generation. The energy that's generated in the sun's core is equivalent to 1 trillion 1 megaton atomic bombs going off every second. This energy is emitted from the sun's surface as light, ultraviolet, and infrared radiation, which is actually essential for life here on Earth. I'm excited that there's a total solar eclipse coming in April this year that should be visible in Ohio, where I am. I've seen a partial eclipse before, and it's a little spooky, so a total eclipse should be worthwhile to watch for. Another spooky thing that is supposed to be occurring this year is that the sun's magnetic poles are expected to flip. North will be south, and vice versa. The sun's magnetic field is generated by a dynamo process involving electric currents within the sun and differential rotation, where the sun's different layers rotate at different speeds. Solar activity, including solar flares and coronal mass ejections, is associated with the sun's magnetic field and often occurs near sunspot groups. As I said, the sun's magnetic poles are about to reverse, a process that occurs approximately every 11 years. This reversal is part of the sun's regular sunspot activity cycle. The flip will likely cause more space weather, including auroras and more intense solar storms for a time. The sun's polar magnetic fields weaken, go to zero, and then emerge again with the opposite polarity during this process. This can have several impacts on Earth, including lower latitude northern lights and more intense solar storms that can cause disruption in satellites, communication, and GPS in space, as well as potentially interrupt electrical power on Earth. Experts predict that there is no overt cause for concern, and while the reversal will have effects throughout the solar system, it's not a catastrophic event. That said, we did have a rather stark reminder that if nature actually decides to mess with us, there's generally bugger all we can do about it. The Carrington event was a powerful solar storm that occurred in 1859. It was named after the British astronomer Richard Carrington, who observed a sudden flash of intense white light from a group of sunspots on the sun. This event resulted in a significant geomagnetic storm on Earth, leading to bright auroras that were visible at low latitudes, disrupted telegraph systems, and caused other electrical disturbances. If a similar event were to occur today, it could have serious consequences for modern technology, such as disrupting telecommunications and power grids. Fortunately, Earth has both a magnetosphere and ionosphere to help shield us from the more undesirable solar emissions. While the magnetosphere protects the Earth from the solar wind and harmful radiation, the ionosphere plays a role in reflecting radio waves and absorbing harmful solar rays. It's most likely that the Carrington event will remain a historical notation, and we'll get through yet another year with our sun helping us instead of hurting us. Hey, thanks for watching, and check out the links below